Solve each equation by factoring. Our first equation, we have 8x squared plus 4x equals 0. A dominant power of 2 tells us that this is a quadratic equation. If you have a dominant power of 1, then it's a linear equation. Let me move this up a little. Now, it will bleed into the next problem, but that's okay. We can handle it. 8x squared plus 4x equals 0. The fastest way to solve a quadratic equation is by factoring. Both of these terms are divisible by 4, and they both have an x. If there's something in common that your terms have, you could factor it out. Take each original term, divide by 4x, and that will leave you 2x. The second term divided by 4x, 4 divided by 4 is 1. Take away an x, there's no more x's. Each factor now is linear because of the power of 1. 4x equals 0 if x equals 0. 2x plus 1 is equal to 0 if 2x is equal to negative 1, which tells us x has to be negative half. Many times you will find quadratic equations have two solutions, and most of the time they are two unique solutions. In our next example, we have the quadratic equation 28x squared minus 4x equals 0. We're going to try to solve this one by factoring as well. Both numbers are divisible by 4. Both terms have at least one x. So I'm going to divide by 4 and take away an x. That will leave 7x minus 1. 28 divided by 4 is 7. Take away an x, that leaves an x. Minus 4 divided by 4 is 1. Take away an x, no more x's. 4x equals 0 as long as x equals 0. 7x minus 1 equals 0 as long as 7x equals 1. X equals 1/7. Two unique solutions. For our last example, we have three terms. The first two have an x in common. The second and third have a 4 in common, but there's nothing in common among all three. There are three terms. That's called a trinomial. With trinomials, you'll have a quadratic term, a linear term, and a constant term. The idea is to split your x into x times x, but to fill in the rest of your parentheses, you've got to pick two numbers that have a sum of b, your middle value, and a product of c, the constant value. Back to our problem, x squared, we're going to split that into x times x, but we've got to find two numbers, and they have to have a sum of 4 and a product of 4. And in class, you guys told me that a couple 2's would do it, and that's right. 2 plus 2 is 4. 2 times 2 is also 4. Since the factors are identical, you only have to solve one of them equal to 0, and this will be 0 as long as x is negative 2. So you actually have two solutions, but it's a repeating negative 2. Our next example is a trinomial as well. X squared plus 10x plus 25 equals 0. Three terms, it's a trinomial. Power 2, it's quadratic. The first two terms have x in common. The second two terms are both divisible by 5, but there's nothing in common for all three at the same time. So we come over here to the side. X squared breaks up into x times x. Try to find two numbers that have a sum of 10 and a product of 25. And you guys told me in class that that was 5 and 5. And that's correct. 5 plus 5 is 10. 5 times 5 is 25. Again, if your factors are identical, you only have to grab one of them, set it equal to 0. So this problem has a repeating solution of negative 5. Now, if you find two numbers that add up to the middle and multiply out to the constant, but they're numbers like 2 and 7, so like if that was a 9 and that was a 14, you would use x plus 2, x plus 7. Then you would have two distinct answers because your factors are distinct. Let's look at another type of quadratic equation. This one's called a binomial. Two terms, binomial, 16x squared minus 49. This is called a difference of two squares. A difference, both terms are perfect squares. What's the square root of 16? 4. What's the square root of 49? 7. So 16x squared will factor as 4x times 4x. 49 factors as 7 times 7. And because we're missing the linear term in the middle, we use opposite signs so that those add up to 0. 4x plus 7 is equal to 0 when 4x equals negative 7, and that means x has to be negative 7/4. This second factor is different, so we have to set it equal to 0. 4x minus 7 is equal to 0 as long as 4x equals 7, which means x equals 7/4. For binomials, you'll have a squared minus b squared in the format. You have square roots, so you'll take the square root of your first term, put that first, square root of your second term, put that second, and then just make sure you use a plus and a minus. That way, when you were to multiply them back out, your outer and inner parts would go to 0. Another technique for solving quadratic equations is called extracting square roots. When you have a square equal to a number, over here in the top right of your screen, this is the general formula for extracting square roots. Anything squared equals to a number, when you square root both sides, anything is equal to the positive and negative square root of that number. Let's follow that blueprint over here. X squared equals 169, so x has to be plus minus square root of 169, which is plus minus 13. There's two solutions, positive and negative 13. In our second example, let me leave that. No, I'm going to pan up a little. Here we go. X squared equals 29, so x equals plus minus square root of 29. Now, since 29 is not a perfect square, you may be asked to approximate. The exact solutions to this equation are positive square root of 29 and negative square root of 29. If you type these into your calculators and round to 3 decimal places, you get 5.385 and negative 5.385. Approximations, exact. You may be asked for both. X minus 6 quantity squared equals 36. This is still in the right format. It's something squared equal to a number. Take the square root of both sides, you get x minus 6, and that has to be equal to positive negative square root of 36. So what does that tell us? X minus 6 has to equal 6 and negative 6. Let's solve for x. Bring a 6 over. It'll go from negative to positive. And then we'll add 6 and take away 6 due to the plus minus sign. When we add, 6 plus 6 is 12. When we subtract, 6 minus 6 is 0. 12 and 0 are the solutions to that equation.